Hey guys, it's Andrew back with another math video. In this video, we are going to be in test 2, looking at number 48 from the math test. So take a second and pause the video, flip to test 2, read number 48 from the math test, and once you've read the problem and thought about it for a second, hit play and we'll walk through it together. All right, friends. This one, as you can probably tell just from looking at it, this is not the easiest question in the test. So if you were going through the tests using our 3-sweep method, on the first sweep, that low-hanging fruit sweep, this is probably one of those questions that you'd skip. And if you are pretty comfortable with trigonometry, this might be a question that you attack on the second sweep, the work sweep of the 3-sweep method. Regardless, we're going to walk through this together pretty methodically. I'm actually going to show you 2 different ways to solve it. The way that requires you to know a lot about trigonometry and the way that requires you to know just a little bit about trigonometry. So let's start. You can see the way I've kind of drawn the problem already. We're approaching this like a word problem. We're going to use our word problem strategy here just to organize our thoughts a bit. Our word problem strategy, of course, 3 steps. In the first step, we ask ourselves a question. We ask ourselves, what am I trying to find? And if you look at the very last line in the word problem, the place where this information usually lives, you figure out that we are trying to find cosine of theta. Simple. We're trying to find what's cosine of theta. Step 2, what do we know? Well, they give us all of the information that we know in this picture. I just redrew the picture on the board, and we're going to kind of use it as we go forward. We know that there's some angle theta starting here at the x-axis, and the angle theta wraps around and ends right here. And that this line, this piece of the angle, the point 4, -3 lies on that line. And it wants to know, just giving that information, it wants us to find what's the cosine of theta. Now, like I said, there's 2 ways that we're going to solve this. The first way, we're going to use the way that requires you to know a little bit about trigonometry. So right away, this is what I noticed. Uncap the old marker. Let's do this. So think about this for a second. If this point is 4, -3, that means to get there, we traveled over this way 4 and down by 3. Okay? So what I've just made, using the information on the board, and this is kind of how the explanation in the back of the book goes through the problem as well. What I've made here on the board is this is a triangle with one side length of 3, another side length of 4, and if you know your special right triangles, you will know that that means the hypotenuse has to be 5. This is a 3, 4, 5 right triangle. All right? Now the second thing you have to know about trig in order to solve this is about something called reference angles. I'm not going to go too deeply into what reference angles are, but I am going to give you just a quick, simple formula. And if you know this formula, you can do the problem this way. If you don't know this formula, you won't be able to do the problem this way. In this triangle that I've just made, I want to look at this angle right here. This angle. You know, if our theta were to go all the way around, the only piece of the full circle that it's missing is this angle right here. I'm going to call this angle something. Because we're using trigonometry and we're using Greek letters, I'm going to introduce you to a new Greek letter. It's one of my favorites. It's called phi. It's basically just a sideways theta. So let's call this angle inside of our triangle phi. Okay? Now there's this special property of these things called reference angles, and that property is this. It says that, this is the formula you need to know, that cosine of phi is equal to the absolute value of cosine of theta. So if we can find cosine of phi inside of our triangle, we can actually learn something about cosine of theta using our formula. So that's what I'm going to do. Let's find what is the cosine of phi. Well, if this is our angle, remember, so katoa, cosine is adjacent over hypotenuse. So let's come over here and calculate what is the cosine of phi. Well, the cosine of phi is the adjacent over the hypotenuse side. What is the adjacent side from phi? It's 4. This is our adjacent side. And what is our hypotenuse side? It's 5. So the cosine of phi is 4 over 5. And we know from our formula that this must also be equal to the absolute value of cosine of theta, okay? So we know that the absolute value of cosine of theta is 4/5. So that means there are two possible values right now for cosine of theta. If the absolute value of cosine of theta is 4/5, that means cosine of theta can either be 4/5 or -4/5. Either one of those, if we plug it into the absolute value, will give us 4/5. So how do we decide? Is it 4/5 or -4/5? Well, let's hop back to our picture here. You'll notice that if we go from here all the way around to here, our angle theta, we end up in, this is the fourth quadrant, okay? And in the fourth quadrant, those of you who know a little bit about trig, cosine is always positive. It has to be positive if we're in the fourth quadrant. So that means cosine of theta can't be -4/5 because it has to be positive. So the answer has to be 4/5. So that is answer choice J. 4/5 is the correct answer. That's how you would solve this problem using knowledge about trigonometry. But I want to show you possibly an easier way for those of you who don't know all of this stuff and this formula and this stuff about reference angles. Okay, here we go. I'm going to erase this. I'm going to get rid of all this triangle stuff here. Take us back to our original picture. So this is our original picture again. And we can learn a couple of quick things from our original picture and use just our basic knowledge about trigonometry. Think about this. Once again, if we start here at our x-axis and move around over to here, following theta, we end up once again in the fourth quadrant. And in the fourth quadrant, if our theta puts us in the fourth quadrant, cosine is always positive. So if cosine is always going to be positive in the fourth quadrant, what can we eliminate? We can eliminate all of our answer choices that are negative. We know cosine has to be positive in the fourth quadrant. So we can actually eliminate the first 3 answer choices just by knowing that. And now we're left with just J and K. We also know, if you know a little bit about trigonometry, that cosine is always between -1 and 1. Cosine of theta is always between -1 and 1. It can't be less than -1 and it can't be more than 1. And if you look at answer choice K, it's 5/4. And K, 5/4 is greater than 1. Cosine can't be greater than 1, so it can't be answer choice K. And now using the process of elimination, you are left with only answer choice J, which is 4/5. So either way, whether you use the mathy nerd method like me, or if you just use the basic things you know about trigonometry, either way you're going to come to J, which is 4/5. That's your answer.